Last year, when I talked about 2.NBT.B.5, I focused on what the standard doesn't require, specifically that stacking numbers and teaching a traditional method is not in the text of the standards. Today, I want to shift that focus. Instead of naming what students shouldn't be doing, this video is about what students should be doing instead. The standards say students should add and subtract using concrete models or drawings and strategies based on place value. So today, we're centering a strategy that grows directly out of place value, expanded form. So let's talk about what this actually looks like in practice. When numbers are stacked, the focus often shifts to what step comes next instead of what's happening to the value. That's where confusion starts to show up, and that's where expanded form comes in. Expanded form is not a trick or a procedure. It's a way to keep the value of a number visible the entire time. Let's look at this problem, 52 minus 38. This is the kind of subtraction problem where stacked methods tend to take over very quickly. If this problem is stacked, students are often pushed toward remembering what to do next, and the conversation quickly shifts from value to digits. Can I subtract 8 from 2? No. So we tell them to borrow from the 5. But here's the issue. We aren't actually borrowing. When I borrow something in real life, I end up with something different than what I had before. In subtraction, we're not borrowing at all. We're rewriting the number in a different form. Then we tell students what to do in terms of their recording. We say, cross out that 5 and make it a 4. And then make the 2 a 12. And that can sound like magic. We can't just change the value of a number. If we could, we'd all be rewriting the value of our checks before depositing them at the bank. What's missing in all of this is an explanation of what's happening to the value. If you feel like you have to stack numbers, expanded form is what keeps the math honest. It forces us to name the value before we act on it. So instead of starting with digits, we start with what the numbers represent. So let's rewrite the problem using expanded form. 52 is 50 plus 2. 38 is 30 plus 8. Right away, expanded form shows us the structure of the numbers. We're no longer working with digits, we're working with value. Now look at each part. I can subtract the tens, 50 minus 30. But I can't subtract 8 from 2 yet. And this is an important moment. Instead of jumping to a step, expanded form forces us to ask what needs to change so the subtraction makes sense. So I regroup on purpose. I don't change the value, I change the form. Instead of 50 plus 2, I write it as 40 plus 12. That's not borrowing. That's recomposing 110 or decomposing 110 into 10 ones. Expanded form makes that move visible instead of hiding it inside a step. Now, let's say the same thinking using place value language. 52 is 5 tens and 2 ones. 38 is 3 tens and 8 ones. If I need to subtract 8 ones, I don't have enough yet. So I decompose 110, and 5 tens becomes 4 tens and 10 ones. So now I have 4 tens and 12 ones all together. The language matches exactly what we did in expanded form. Nothing changed. We're just naming the structure more explicitly. Now that the value is clear, the subtraction itself is straightforward. I'm using basic facts to subtract the ones and the tens separately. 12 ones minus 8 ones is 4 ones, and 4 tens minus 3 tens is 110. And that makes sense because at this point, students are still building fluency within 20. That's why they often try to subtract down some columns and up others. They're leaning on the facts they actually know. Expanded form honors where students are and gives them a way to use those facts accurately and intentionally. Expanded form isn't about adding a new strategy. It's about keeping the value visible so students can use the math they actually know. In grade 2, that means leaning on place value, using basic facts intentionally, and building fluency without rushing procedures. That's exactly what 2.NBT.B.5 is asking for. If you're thinking about how this shows up on an anchor chart or a poster, that's something I'm going to dig into more in this week's Thursday teaching tip, because how we represent this thinking matters just as much as the strategy itself.